As far as the exponent is concerned, an exponent is written in terms of a base, which is represented as a in this, and a power, which is represented by the n. Okay, so when you're looking at an exponent is just another way to represent repeated multiplication. And so really, a to the nth power means you're taking a times a times a times a total of n times, okay, whatever n is. And so all that, again, should be stuff that is review for you. Are there any questions about the form of an exponent? And remember, in using your calculator, the exponents are entered with that caret symbol. So 5 cubed is written as 5 to the power of 3. This is also how it will be represented on the computer as far as the homework and stuff and those submissions would be concerned. Okay, so be aware of that. It's the only way to designate the scientific notation without being able to insert the mathematical objects. Right, there's several properties of exponents that you need to be familiar with. You should have been exposed to these before, but if you take two exponents with the same base and you multiply them, you guys remember what you do with their powers? You add the powers. Okay, so when you're looking at this, 5 cubed times 5 squared is equal to 5 to the 3 plus 2, or 5 to the 5th. Okay. How about if you take a base to a negative power? Does it change the sign of your number? Is this right? This is the most common mistake. Okay? Students take and change the sign. Okay? It does not work that way. Okay? Don't change the sign of your number. And this power, a negative power, simply means you're taking your base and you're moving it into the denominator, or vice versa. So we move this base of a into the denominator, change the sign to positive, and so it just takes the reciprocal of your base. If the negative power had been in the denominator to begin with, you'd move it up to the numerator and change its sign to a positive. Okay, so if you're looking at 5 to the negative 2, that's like saying taking your base of 5, moving it to the denominator, changing the sign of its power to positive, which you could then simplify to 1 over 25. Okay, what if you take the power of a product? So this is the product of powers. If you multiply two powers, you also have a rule called power of a product. Okay, so if you take some product, a times b, and your power m applies to that entire product, you could simply apply this power to each individual factor. So all factors that are grouped together with a power applying to them will be taken to that power. So this is equivalent to a to the m times b to the m. And now the place where you're going to see this would be something like this. And if you have 3x quantity cubed, that cube doesn't just apply to the base x. Here, anytime there's no grouping symbols, the power only applies to the base it's attached to. And when there's grouping symbols, that power will apply to all factors of the product. So this can separate into 3 cubed times x cubed. 3 cubed reduces, or can be simplified to 27. X cubed would be the simplified form for that. Okay, this rule works for a quotient as well. The power of a quotient rule states if the power applies to a quotient, then it's going to apply to each of those independently as well. So you would get a to the m over b to the m. And so again, if you're looking at taking something like 2/5 squared, this is equivalent to saying You take 2 to the second power, you take the base of 5 to the second power, and then simplify each of them as much as you would need to get your simplified form. All right, if we go on to a couple other properties. If you take the quotient of 2 powers that have the same base, this is really equivalent to taking your numerator, and then if we took this base from the denominator and we moved it up, what would we have to do to the sign of its power? It becomes a negative, which would then be the rule of taking the product of powers. When you multiply 2 numbers with the same base, what do you do with their powers? So m plus a negative n. And so really the separate rule is when you divide 2 numbers with the same base, what do you do to their powers? You could subtract them. So instead of having to go through this additional step of moving the base from the denominator, you can just go straight to when you're dividing 2 numbers with the same base, you can subtract their powers. So 5 to the 5th over 5 squared is equivalent to 5 to the 5 minus 2. My expectation as far as using no calculators are concerned, you know perfect cubes up to 6 cubed. So 1 cubed is what? 1. 2 cubed is? 8. 3 cubed is? 27. 4 cubed? 64. 5 cubed?
125.
125. 6 cubed is 216. Okay, so you should be familiar with those. If you needed to calculate them, you should be able to take your perfect square, multiply it by that number one more time, and solve it by hand relatively easily, if that's the case. All right, the next rule is a power of 0. Anytime you take a number to the power of 0, it's equal to 1. The exception is, or the rule is, a cannot equal 0. Okay, so as long as a is some number other than 0, when you take that base to the power of 0, you're going to get a value of 1. Okay, so if you look at something like this, 7 to the 0 gives you a value of 1. What about negative 7 to the 0? Would this be 1 or negative 1? All right. As far as the anatomy of an exponent, you have a base and you have a power. Okay. Unless there's grouping symbols, the power only applies to the base it's attached to. Okay. Is this base that the power applies to 7 or negative 7?
7.
It's a 7. So you have to do order of operations. So here is where exponents fall. Okay. So you have to do the exponents before you do. The negative sign is just a change of sign representation. It means that you're taking whatever quantity this is and you're multiplying by negative 1. So really a negative 7 is the product of negative 1 times 7. So the way that this was written here, negative 7 to the 0, you would have to do the exponent first. 7 to the 0 is 1, and then multiply by a negative. So your overall answer would be a negative 1. Now, what if it looked like this? Now what's this? What's the base that the power of 0 is applying to? It's this whole base, and so now anything taken to the 0 power is 1. Okay. Or you could also think of this in terms of the power of a product rule, and you could say that negative 1 to the 0 times 7 to the 0 is, again, if you broke this into the product of those two factors, again, anything to the 0 power is 1, anything to the 0 power is 1, so you'd still get your 1 if you broke it up that way. Okay, but be really careful of order of operations when you're dealing with powers. Okay, I will try to trick you with negative signs in front of bases without the power applying to the negative sign.